Hey class, it's Mr. Gorman. Hope that this is going to be a new fun way for you guys to learn with the videos. I'm really excited about it, so let's give it a shot. We're going to start off with doing our fraction unit, and the very first thing I want you to learn is about vocabulary. So here we go. What you need to have success in this lesson, you need to be willing and ready to learn. If you're not willing and ready to learn right now, turn off the video, close your computer, stop doing what you're doing, come back when you're ready to learn, because no matter how good your teacher is, whoever your teacher is, you're not going to learn something unless you really want to, okay? Why do I care? And that's not why do I, Mr. Gorman, care, that's why do you care. You should ask yourself this question. You care because mastering this vocabulary is going to make it so much easier for you guys when we get into doing the actual math, all right? And finally, my goals for this lesson, okay, is to provide you guys important terms and definitions that are going to be used throughout our fractions unit. I want you to learn them and get them down first, so it's easier later. So that way when your assignments start asking you to find a greatest common factor, even if you know how to find a greatest common factor, if you don't know what that is, it's not going to be able to be a good problem for you. Okay, and then finally is to give you a little basic idea about these things. I am not teaching you how to find these things or do this math. I want you to learn the vocabulary and give you some pictures and examples. Okay, here we go. Prime numbers. Prime number says a number with only two factors. Well, we're going to start down here with factor because of that. So a factor, that's a number that's multiplied. So let's look at 3 times 4 equals 12. Well, our number that's being multiplied is 3 or 4. 3 and 4 are our factors. So a little bit of a review. 12 is your product. Okay? So kids, when you're watching this video, make sure that you stop and pause every once in a while when you need to re-listen to something. I'm your little monkey, make me do my dance, rewind, fast forward, re-listen, and relearn. Okay? A prime number is a number with only two factors, and those two factors are going to be 1 and itself. Okay? 1 and itself, that means, for example, with 3. The only way to get to 3 is 1 times 3 equals 3. Now you're going to tell me there's another way to get there. I know 3 times 1 equals 3. Well, guess what? Even though you wrote the problem a different way, you still only used two different factors. You used a 1 here and a 3 there. Guess what? You used that same 1 there and 3 there. Two factors, okay? 1 is not a prime number, because 1 only has one factor, 1 and, well, just 1. 1 times 1, okay? 1's not a prime number, so the first prime number is 2, then 3, then 5, then 7, and so on and so on and so on, okay? 1 and itself. Next up, we've got composite numbers. A composite number is still going to have that 1 and itself, 1 and itself, but it's also going to bring its friends, invite some people over to hang out, okay? So I want to look at 6. It's a very easy one. 1 times 6 equals 6. There's our 1 in itself portion, okay? But now I'm going to do the plus friends, and that's going to be 2 times 3 equals 6. This plus friends section right there, that's what's going to make it a composite number, okay? It's got down to multiples. I have down here for multiples that a multiple, okay, a multiple is a number that can be reached using whole numbers multiplied together for a given factor. So our given factor, I want to look at the factor 12, okay? It's a number that's not super hard but also not super easy. So we're going to actually just kind of count by 12, okay? 12. With another 12 is 24. With another 12 is 36. With another 12 is 48. With another 12 is 60. So you can see that this is 12 times 1, and then 12 times 2, and 12 times 3, and 12 times 4, and 12 times 5. Okay, so any number, the multiples, 12, 24, 36, 48, 60, those are all the numbers that we can get by using multiplication. Again, 12 times 1 times 2 times 3 times 4 times 5. Prime factorization. A list of prime factors for a specified number. So let's specify a number. I'm going to use kind of a big one, but it's going to be okay. 120. Now, we know some easy ways to get to 120 with multiplication is 12 and 10, but we want to list the prime factors. So what we have to do is use a factor tree to break it down. Okay, so 12 and 10 right there. Now, I can break 10 down because it's still a composite number into 2 and 5. The good news is, though, that 2 is a prime number and 5 is a prime number. So I've finished with that whole branch. Next up, we're going to break down 12. I'm going to use 3 and 4. Now, 3 is a prime number, but 4 is not, so I need to keep breaking it down, and I have a 2 and a 2. Notice one thing I'm doing is circling all of my prime numbers. Let's call them, when we get to the prime numbers, let's call them our leaves. When you get to your leaf, okay, when all of your branches end with a leaf, you've finished your factor tree. So now all we need to do is write out our prime factorization. We have 120 is going to equal 5. Notice I'm crossing them out as I go so I don't mess up. 5 times 3 times 2 times 2 times our last leaf 2. Okay? If you want to write it with exponents, you can do that. It would be 120 equals 5 times 3 times 2 to the 1, 2, 3, third power. Very good. As we move on, I'm going to just give you a little heads up. I'm going to do that, okay, just so that we can see it. Don't delete it on yours. And by delete, I mean erase. Don't erase it on your sheet of paper, please. We're going to move on. Our greatest common factor. Greatest common factor. Well, our greatest common factor is the largest number shared by, I should say, 2 or more numbers. 2 or more numbers. So let's give you 2 numbers. We're going to work with 12. And we're going to work with 30, okay? Factors, remember from up above, are numbers that are used to multiply. So we're looking for the biggest number we can use to multiply to get to both of them. So we need to find all the numbers we can use to get to multiply them. So 1 times 12 equals 12. 2 is next. 1, 2, 3. Yeah, so 2 times 6 equals 12. 3 times 4 equals 12. All right? Those are all the different ways to get to 12. Now let's do 30. 1 times 30, 2 times 15, 3 times 10, 5 times 6, 30, 30, 30. Okay. We need to find the biggest factor. The biggest factors are the ones you're multiplying together, the biggest one that's in both lists. Now, none of it could be bigger than 12 because 12 is the smaller number. Any number bigger. So look in the smaller list first. 12, is there a match? 30, 15, 10, no. 6, is there a match? 30, 15, 10, 6. Yes, we found a match. 6 and 6. 6 is your greatest common factor. That's what a greatest common factor is. The biggest number that you can use to get to both numbers with multiplication. Least common multiple. This is a little bit different. This time we're going to do multiples. But we want the smallest one that it has. Okay? We want the smallest one. So we're going to use those same numbers, 12 and 30. But we're going to need to list all of their multiples. So 12 times 1 is 12. We've got it. 12 times 2, 24, 36, 48, 60, 72, and let's stop there. 30, 60, 90, sorry, 120, 150, 180. All right. Luckily for us, some of you probably already noticed, 60 is the first number in both lists. That means 60 is our least common multiple. Okay? I'm not going to go into more detail about this because this is just vocabulary. Remember, we're going to start with the actual math parts once you've got this vocabulary down. Fraction, numerical representation of parts of a whole or parts of a set. Okay, well, parts of a whole, we've got a whole pizza here. I split it up into 4 pieces. Okay, so if I have 1, 2, three pieces of pizza there. That means I have 3 out of 4. So over here, this was parts of a whole. I have 3 parts of my whole pizza. It took 4 pieces to make a whole pizza. Over here, we're going to do parts of a set next. Okay, let's say you get a package of markers. Okay, here's our markers package, and you can see all of them in there, right? So our markers package is going to come up with 10 in them. Okay, so out of 10 markers, after about 2 days of using them here in the 6th grade, most of our packs only have 6 out of the 10 markers left. Okay, that is a part of a set. It takes 10 markers for a whole set, and we only have 6 of them in here. For parts of a whole, we only have 3 out of our 4 slices of pizza. Numerator. Numerator, let's look at our pizza again. Our numerator is the top number in the fraction, and it represents the number of existing parts, the number of parts that we have, right? I have 3 pieces, so my numerator is 3 out of 4 total, okay? Top, bottom. For our denominator portion, I'm going to pull this down, but we're going to keep our marker example, okay? We had 10 markers to make a set, so I'm going to put 10 down here because that's how many it takes to make a full box of markers. We only had 6. Again, top, over, bottom. Okay? Those are what those 2 different parts are called. We're going to keep going on your work here. Equivalent fractions are fractions that equal each other but have different numerical representation. Remember, numerical representation just means the numbers we're writing down. Okay, so if I'm gonna take a look at another pizza. Okay, I've got this pizza at home. You know, it's just me and my wife. So we're gonna cut the pizza in half. I get 1 out of 2 of those pieces. Okay, out of that whole pizza. But let's say that we have friends visiting, and I am a greedy Mr. Gorman. Okay, we have just that one friend coming, so we have 3 people. So my wife's going to take 1 piece, okay? My friend is going to take another piece, and I'm greedy, so I'm going to take my 2 pieces. That's for me. So I have 2 out of the total 4 pieces. Now you can easily see that my 2 out of 4 is the same as my 1/2 here, so 1/2 equals 2/4. Those are 2 fractions that are the same amount. They equal each other, okay? But they have different numerical representations, 1/2 and 2/4. Great. We're going to use this example right up here to simplify. That means reducing the numerical representation. Remember, numerical representation just means numbers. Okay, reducing the numbers, making them smaller of a fraction by dividing both the numerator top, denominator bottom by common factors. Okay, well, I'm going to start here. To reduce it down, I have 2 pieces of pizza out of 4, okay? But I can make that easier to understand if I divide the top and the bottom by the same factor, okay? The common factor for 2 and 4 is 2. So if I divide by 2/2, if I have 2 parts of 2 total parts, I have 1. I have 1 whole. So I'm really just dividing by 1 here. 2 divided by 2 is 1. 4 divided by 2 is 2. I have now reduced, okay? Lowest terms, the simplest form of a fraction, it can be reduced no further, okay? 1/2. My example from up there, I can't reduce that any further. There are no more common factors besides 1. But if I divide it by 1, 1 divided by 1 is 1, 2 divided by 1 is 2, I get the same fraction. Can't make it any smaller. Let's look at another one real quick. I'm going to do 6/10. Okay, a common factor that they have is 2 divided by 2. I'm going to get 3/5. Okay, 3 and 5 have no more common factors except for 1, but that won't actually reduce. So it is in lowest terms. Okay, we cannot simplify or reduce it anymore. Next, mixed number. Mixed number is a whole number and a fraction. We're going to have a pizza party. There's our pizzas. After the first zone goes through, okay, we're going to have Out of these 3 whole pizzas, I'm going to color this one in. There's 1 whole pizza. Here's 2 whole pizzas. But after zone 1 goes through, we've only got 1, 2 pieces left in there. So we have 2 whole pizzas, whole number, with a fraction. And here we have 2 out of a total 8 pieces left. So we have a whole number with a fraction. All right. An improper fraction. It's going to be the same idea, but instead of writing the whole number, we're going to count the individual parts. So within this pizza, remember there's 1, 2, 3, 4, 5, 6, 7, 8. I have 8 parts in that pizza. And in here, I'm going to have 8 parts again. Okay? And in this one, I have my 1, 2. I only had 2 parts of that. Okay, so I have 2. 8 plus 8, 16. Plus 2, 18 over my total parts for 1 pizza. You keep the same denominator like up there. I have 18 out of 8. That is what an improper fraction looks like. The numerator right there is larger than the denominator right there. Okay. Finally, last term. Here we go. Reciprocal. Reciprocal. A number that gives a product of 1 for a specified number. Okay, my specified number. I'm going to have a specified number of 2. 2 times what number? This is going to be your reciprocal right there. Right there equals 1. Now, some of you know that what you need to do with 2 to get 1 is to break it up into 2. Well, the same thing for dividing by 2 is multiplying by half. Okay, but for fractions, what we're going to do is we're actually going to change this 2. We're going to change that 2 into an improper fraction. We can do that by 2 over 1 because 2 divided by our fraction bar 1 divided by 1 is 2. Okay, so what we can do to easily find our reciprocals, I should erase that. I'll show you real quick. To find our reciprocals, all you're going to do is flip your numbers. We're going to have 1 over 2. 2 times 1 equals 2. 1 times 2 equals 2. 2 divided by 2 equals 1. That, my friends, is our first lesson. Hope it was good. Rewatch it, pause it, study it, raise your hand with questions. Let me know when you're ready to take the quiz. Good luck.